Hello viewers, welcome to Physics Facilitator. So in today's session we are going to continue motion chapter and videos on this topic have been uploaded in our channel. Please do check that videos also. So now let us begin our session. Acceleration. So what is acceleration? Suppose ఒక కార్ ఏ పాయింట్ దగ్గర ఉంది. ఈ ఏ పాయింట్ నుంచి బి పాయింట్ కి ట్రావెల్ అయింది. సో లెట్ us say the velocity at B point is 6 meter per second, okay, and it have obtained that velocity in 3 seconds, okay, and again a car B nunchi C ki travel avutundi. Let us say the velocity at C is 12 meter per second. Then how you will find the velocity change of that car traveling from A to B and B to C? Ela find chesam velocity change ni? Simply we will say final velocity minus initial velocity, right? Delta V equal to Vf minus Vi, right? If you are finding in case of A to B, then what is Vf? Vf is nothing but final velocity of that particular car or object which is moving, okay. So Vf enti ee situation lo it is 6, right? Enduku final point enti B. So at this point what is the velocity of the car? 6, right? So we will write 6 minus Vi ante enti initial velocity. So initial velocity ఎంత ఉంది కార్ ది ఏ పాయింట్ లో కార్ ఈజ్ ఎట్ రెస్ట్, రైట్? సో రెస్ట్ లో ఉన్న కార్ వెలాసిటీ ఎంత ఉంటుంది? ఇట్ విల్ బి 0, రైట్? 6 minus 0 equal to 6 meter per seconds. So velocity change ఎంత ఉంది A to B ki? 6 meter per seconds. Now B to C. If you want to find the change in velocity in case of B to C, then what you will do? Same, Vf minus Vi. So Vf final velocity enta 12, right? At C velocity of the car is 12. So 12 minus ఇక్కడ B ఏమవుతుంది? ఇనిషియల్ పాయింట్ అవుతుంది, రైట్? A to B ఉన్న సిచ్యువేషన్ లో A ఇనిషియల్ పాయింట్ అయింది, B is ఫైనల్ పొజిషన్. బట్ when it is again traveling from B to C, B ఏమవుతుంది ఇక్కడ? It will be initial position of that car. So the velocity at B will become initial velocity of that car. Okay, so B దగ్గర ఎంత ఉంది velocity కార్ ది? 6. So 12 minus 6 equal to 6 meter per seconds, right? సో ఇక్కడ మనం ఏం ఫైండ్ చేసాం? వెలాసిటీ చేంజ్ ని ఫైండ్ చేసినాం. కానీ ఒకవేళ పర్ సెకండ్ ఎంత వెలాసిటీ చేంజ్ అయిందని మనం ఫైండ్ చేయాలనుకుంటే ఏం చేస్తాం? డివైడెడ్ బై దట్ టైం, రైట్? సో ఇక్కడ 3 seconds ఉంది. సో 6 divided by 3. Now what you will get? 2 meter per second square, right? So this is the change in velocity per second, okay. In next situation, that is B to C, let us say here it have taken 6 seconds, okay. So by 6, so 1 meter per second square, okay. By this you are finding velocity change at that second, okay. So idanta enti? What we are doing here? We are finding the change in velocity of that particular moving object, right? So that change in velocity is nothing but acceleration, okay. Now let us see the definition. The rate of change of velocity of an object is known as acceleration. That is acceleration nothing but it gives us an idea about change of velocity, okay, of particular moving object or moving body, okay. So ఇంకొక ఎగ్జాంపుల్ కూడా తీసుకుందాం. ఇఫ్ సపోజ్ ఒక కార్ ఏ పాయింట్ నుంచి మూవ్ అవుతుంది, బి పాయింట్ కి మూవ్ అయింది. Let us say till reaching B it have 30 km per hours velocity. Again B to C move అయినప్పుడు 35 km per hour అయింది ఆ velocity. Again C to D అయినప్పుడు 40 km per hour అయింది ఆ velocity. So what is happening here? Velocity అనేది 5 km per hour increase అవుతుంది ప్రతి ఒక్క స్టేజ్ తో. So what is happening here? The velocity is changing. So this is nothing but acceleration. The body has been accelerated. Ante acceleration ante enti? We are giving extra energy, extra force to move that body, okay. So ikkada 0 on the velocity, okay. What we are doing? We are pressing the accelerator of that car and increasing the velocity of that car. Why? To increase its speed. Again, what we are doing? At point B, we have 30, but we are pressing again accelerate to increase its speed. So what is happening? Again, its velocity is increasing by 5 km per hour. 5 kilometers increase అయినప్పుడు ఏమవుతుంది, దాని స్పీడ్ కూడా ఇంక్రీజ్ అవుతుంది. సో లైక్ వైజ్ వీఆర్ accelerating the car, we are increasing the speed of the car. Okay, so this is called as acceleration. Okay, the rate of change of velocity is called as acceleration. ఓకే, సో డే టు డే లైఫ్ లో కూడా మనం ఈ యాక్సలరేషన్ అనేది ఎక్స్పీరియన్స్ చేస్తాం. లైక్ ఇఫ్ యు ఆర్ ట్రావెలింగ్ ఇన్ ఏ బస్, డ్రైవర్ యాక్సలరేటర్ ని ప్రెస్ చేసినప్పుడు ఏమవుతుంది, మన బాడీస్ సీట్ కి అగేన్స్ట్ గా ప్రెస్ అవుతాయి. సో అవర్ బాడీస్ ఆర్ ఆల్సో ఎక్స్పీరియన్సింగ్ యాక్సలరేషన్, రైట్? సో దిస్ ఈజ్ కాల్డ్ as acceleration. Now, acceleration only increasing velocities కి అప్లై అవుతుందా? No, decreasing velocities కి కూడా అప్లై అవుతుంది. That situation where we have decreasing velocities, that is called as deceleration. Okay, so increasing velocities ఉన్నప్పుడు acceleration, decreasing velocity ఉన్నప్పుడు deceleration. So deceleration, or it is also called as retardation. Okay, so deceleration ఎక్కడ అబ్జర్వ్ చేస్తాం? If you are standing here on the ground and you are throwing a stone into the sky, what will happen? ఇక్కడ వరకు దాని వెలాసిటీ ఇంక్రీజ్ అయింది, కానీ ఒక పాయింట్ వచ్చాక దాని వెలాసిటీ ఏమైంది, డిక్రీజ్ అవుతుంది. సో దిస్ decreasing of velocity is called as deceleration. Okay, the gradual decrease of velocity of a body is called as deceleration. And you will have a term uniform acceleration. Okay, that uniform acceleration is applied where the rate of change of velocities are equal in equal time intervals. Okay, so ఈక్వల్ టైమ్ ఇంటర్వెల్స్ లో ఈక్వల్ రేట్ ఆఫ్ చేంజ్ ఆఫ్ వెలాసిటీస్ అక్కర్ అయినప్పుడు దాన్ని యూనిఫామ్ యాక్సలరేషన్ అంటాము. ఓకే, సో డీసెలరేషన్ కి ఎగ్జాంపుల్ ఏమనుకోవచ్చు? ట్రైన్ ఎగ్జాంపుల్ తీసుకోవచ్చు. ట్రైన్ ఎలా ఆగుతుంది? బ్రేక్స్ సడన్ గా వేస్తారా? నో, రైట్? ఒక స్టేజ్ కొంచెం డిస్టెన్స్ లో ఉన్నప్పుడే బ్రేక్ వేస్తారు. అప్పుడు దాని వెలాసిటీ ఏమవుతుంది, గ్రాడ్యువల్ గా డిక్రీజ్ అవుతుంది, ఒకటేసారి డిక్రీజ్ అవ్వదు కదా. సో దాట్ గ్రాడ్యువల్ డిక్రీజ్ ఆఫ్ వెలాసిటీ ఈజ్ నథింగ్ బట్ ద ట్రైన్ ఈజ్ డీసెలరేటెడ్. ఓకే, ట్రైన్ స్టార్ట్ అయ్యేటప్పుడు ఏమవుతుంది, స్లోగా స్పీడ్ ని పికప్ చేసుకుంటుంది. సో ఇట్ ఈస్ యాక్సెలరేటెడ్. When it is stopping, it is decelerated. Okay, and acceleration is a vector quantity. Ante vector quantity ante enti? It gives both direction and magnitude. Okay, and the SI units of acceleration is meter per second square. Okay, we have observed in this case, right? We have got meter per second square. How we have got that? Displacement by time, right? That is acceleration. Equations of uniform acceleration motion. So just now we have read what is uniform acceleration motion, right? It is nothing but whenever the rate of change of velocities are equal in equal time intervals, then that object or body which is in motion comes under uniform acceleration motion, right? So now we are finding the equations of that uniform acceleration motion. So to find the equations of uniform acceleration motion, let us say a car is moving in a straight line or a straight path. Okay, now let us say this is the starting point. At starting point t equal to 0 seconds, right? So at t equal to 0 seconds, let us say the velocity of the car is u. Okay, now the car has a displacement of s, and let us say the car is at this point now. Okay, at t equal to t seconds, the car has a velocity of v with a displacement of s. Okay, now we are assuming acceleration as constant, that is delta v by delta t is constant in this case. Okay, now what we know by the formula? Acceleration equal to change in velocity by time taken, right? So what is change in velocity here? How we will find the change in velocity of a moving object? Simply we will write as final velocity minus initial velocity, right? So in this case, what is final velocity? It is v, and what is initial velocity? It is u, right? So v minus u by what is time taken? It is t. So what you are getting from this? A equal to v minus u by t, right? So now let us take this t to other side. You will get at equal to v minus u. Now let us take this u to other side. Then what you will get? U plus at equal to v, right? So let us say this is equation 1. Okay. Now since we are assuming acceleration as constant, then average velocity will be v plus u by 2. But we know average velocity formula as displacement by time, right? So what is displacement in this case? Yes, right, this is displacement. And what is the time? T, right? Now let us substitute this average velocity v plus u by 2 here in average velocity place. Then what you will get? V plus u by 2 equal to s by t. Okay, now let us say this is equation 2. Okay, now we have got equation 1 and equation 2. Okay, next. Now let us put v equal to u plus at, that is equation 1 in equation 2. What is the second equation we have? V plus u by 2 equal to s by t. Right. So we are substituting v value, that is u plus at in this equation. So what you will get? U plus at plus u by 2 equal to s by t. So what you will get? 2u plus at by 2 equal to s by t. Now let us separate the denominator. 2u by 2 plus at by 2. So what you will get? 2 will get cancelled, right? So what you will get here? U plus at by 2 equal to s by t. Okay. So now let us take this t to other side. What you will get? Ut plus half at square equal to s. So now let this be equation 3. Now again from equation 1, v equal to u plus at, we will take t separate. Okay. T equal to v minus u by a. Right. So now let us substitute this t value in equation 2. Okay. What you will get? What is equation 2? V plus u by 2 equal to s by t. Right. This is equation 2, right? So first we will take this t to other side. So t into v plus u by 2. So let us substitute the value of t here. V minus u by a into v plus u by 2 equal to s. Right. So what you will get? V square minus u square by 2a equal to s. So let us take this 2a to other side. V square minus u square equal to 2as. So let this be fourth equation. Okay. From this we have got three equations. First one, v equal to u plus at. Right. And second one, s equal to ut plus half at square. Third one is v square minus u square equal to 2as. These are three equations of uniform accelerated motion. Okay. So that's all for today's session. In next video, we will solve few problems on the topics which we have covered and we will end this chapter. Please do like, share and subscribe to my channel.